Going to continue our little journey here down the polynomial path, but actually I want to compare it a little bit more to a tool belt. Maybe I get the sense that I enjoy working with a good tool now and then, so I thought that we would take the things we're learning about polynomials and kind of compare them to a little tool belt. And just so you understand what tools we've gotten as nice gifts over the last just couple days. So what's the most fundamental tool in your polynomial tool belt? Well, it's like the first thing we did, but you did it remotely with me. And it's the idea of plugging in a number. And if you plug in a number, you can see if it equals 0. It's kind of one of those things sometimes we forget about, but don't, because it's a really helpful tool. And so whether you're into tools or not, can you imagine the most fundamental tool that would probably be in your tool belt? Okay, you swing it, and if you hit it just right, okay, you'll be able to drive that nail in. So we have a hammer as our sort of our comparison. What other tools do we have in our polynomial tool belt? Again, these are just over the last few days. Well, you could factor. You could factor, of course. You know all about factoring. Now, factoring is kind of like cutting up a polynomial, like a saw. Now, I have chosen here like a hand saw because factoring is kind of like a hand method. It's kind of like doing the problem sort of the old-fashioned way if you factor something. What other tools do we have? You're just interested in what tool's going to come up here, or maybe you're not. But what about if you graph the polynomial? Of course, we did that on the first day. The thing about graphing is that it requires some power, right? So now we need some juice. We need a power drill. I just chose a drill because it has power. I don't really know what that has to do with a graph. Okay, now the thing about all these methods is they are nice if you can apply them. And if you would like, you can take a look at this equation. Eventually you'll want to jot it down, but we just want to kind of consider, how do these tools work with this equation? So again, the main thing is, how do these tools work with this equation? If you look at the first tool, I don't have any numbers to plug in. And I don't know about you, but there's a lot of numbers out there. So I don't want to just start plugging numbers in. Okay, it's going to take too long. It's probably going to be a waste of time. How about factoring? Can you find two numbers that multiply to be 10 and add to be -8? I know sometimes factoring gives kids the heebie-jeebies, but there ain't two numbers that multiply to be 10 and add to be -8. You can't factor this. It's not factorable. Ah, darn. Kind of striking out with my tool belt here. How about graphing it? Yeah, we could graph it. Oh, man, but my calculator's out of batteries. Now, you could graph it if you want, but what you're going to discover is that the roots are not integers. We would call them irrational. And we're just going to save a few moments, and just trust me, if you graph this, you're going to have a root that is kind of like, again, a decimal that's irrational. Okay, you wouldn't know that unless you would continue to work with this equation with a new tool. Now, this tool is a specialized tool. It's one that is going to allow us to do something called completing the square. Now, you may have done this before, but you may not have. This is one of these things where sometimes kids are like, oh, I never saw that before, which is great because we're trying to do new things in here. Now, completing the square is a very specialized tool, so we need a specialized coping saw. What's a coping saw? Okay, well, it used to be a tool that I would go downstairs in my dad's basement and just kind of use because it looked like a saw and it was kind of small and simple, and a little kid couldn't hurt themselves too badly. But actually, a coping saw is used to hang crown molding, a very specialized woodworking skill that sometimes is kind of losing its dwindling. Not too many people do it anymore, but basically the corners of crown molding need to be coped. That means you have to cut them you have to cut back into them so that they fit into this profile. And when you cope something correctly, you get a nice corner on crown molding. Okay. The point here is that it's a specialized tool. I'll give lessons at the end of the day if you want. You can come back. But let's talk about completing the square with this equation. You're going to like this. It's neat. You're going to kind of feel smart when you're done. And I don't want to say it takes a lot of work. It just takes being careful about how to approach the numbers in this equation. And you're going to find that we literally complete the square. Now, to do this, you're going to find out that I'm going to group the first two terms, or said maybe a little bit better, I'm going to push this third term out of the way. It's kind of sad, but we say, hey, 10, get out of here. You're not going to be part of this specialized completing that we're going to do. Now, you notice, I hope you notice here that I left space for a number. I left space for some certain number that's going to complete this square. And if you're like, huh? Well, just watch, because we're going to put a number in here. Okay, now it has to be a number that when you look at this -8, allows us to complete the square. And the answer to that, or the question that you ask yourself is, what is half of this number squared? What is half of this number? -4. What is that squared? 16. And so half of that number squared produces the number 16, which happens to be kind of like the most important number for this problem. Now, if you're like, wait a minute, you can just add a 16 in there? Well, yes, as long as you also subtract it from here. You see, you have to keep in mind that the problem started as given. And I can't just get in here and just magically put a new number in unless I undo that number. So I put in a 16, I take out a 16. By the way, it always works this way. Now, why did we put a 16 in here? Well, I'm glad you asked. Okay, I'm glad you asked. Let me write down a couple things that are definitely true, but then I want to get to that question. Why did I put a 16 in here? Take a look at what I've done here. I've definitely taken 10 minus 16 and just simplified it. I've also prepped this to be factored. Look, because of this 16, I am now able to write this as a binomial squared. And simply remembering how we got the 16. It came from half of -8. It came from -4. Or you might just say simply that I factored that perfect square. Listen, when you put 16 in, you complete the square, which enables you to write the equation as a perfect square, as an x minus 4 squared. Okay, now we're going to finish solving the problem. Sometimes kids are like, why are you doing this? Well, because we're going to solve it for x. But before we do that, I just want to pause one more time. Everything that's on the board is equal. It's equal to what I started with, but now it's of a special form. Okay, and now we can solve it. So let's do it. I don't know if you really need my permission to add 6 to both sides. And I don't know if you really need my permission to take the square root of both sides. We're solving for x. Don't forget when you take the square root that you get plus or minus. That's pretty important. And do you need my permission to add 4 to both sides? But let me encourage you that those are the right steps. So we get 4 plus or minus root 6. 4 plus or minus root 6. Okay, now, if you think back to our little tool belt discussion, we were after those roots in the first place. We just found them. They are known as a conjugate. They're a conjugate because they are in the form of plus or minus. But the bottom line is that they are irrational. They are two numbers, one of them being 4 plus 4 minus root 6, the other one being 4 plus root 6. By the way, I've noticed that I'm creating the position of these numbers just based on their approximate value. But if you're like, what is 4 minus root 6? You could find it on a calculator. Obviously, turn it into a decimal. But it's going to be something where one of them's to the left and one of them's to the right. And then we can draw a graph that has the behaviors that we talked about yesterday. Of course, I hope you just draw a graph that looks like a parabola as that's what I started with in my original equation. Okay, but we were able to find those roots using this new strategy. I want to do one more problem, and I have like a couple steps. Sometimes steps are helpful for kids, but for most of us, it's going to be understanding how to apply this technique. And so let me just show you with another equation. There is something about this equation that's going to be a little bit more challenging. Maybe you just notice in the first place that it's got some bigger numbers. 2x squared minus 20x plus 65. Now, I'm telling you the truth that you always group the first two terms. Maybe better said, you always push that constant out of the way. The other thing that you may not realize, but I want to tell you in this problem, is that you always need a leading coefficient of 1. Therefore, I must factor out the 2. So take a look at how I'm kind of prepping this equation. Definitely I'm factoring out the 2, because whether you realize or not, I must have a leading coefficient of 1 on my x squared. And simply that's so that I can focus on sort of the essence of this number in the middle, and that is that I need half of this number squared. Now half of negative 10 is negative 5, and of course when you square negative 5 you get positive 25. So I always want to put in half of that number squared. Are you ready? Here's kind of a little catch to this problem. Did I really add 25 to the essence of this equation? Well, the answer is no, because I've really added 2 times 25. That means I need to undo. I need to undo 50. How do you undo 50? By subtracting it. Okay, and that's something you always have to be careful about when the leading coefficient is greater than 1. Maybe already you feel like you can continue with this problem. I'm just going to pause in case you want to think about it. I'll write something down in case you want to look up here. This is an important step. If you want to look, you can see that I have gotten the equation ready. I've gotten it ready to be in this factored form. I hope you don't think too hard about the problem that goes inside this binomial, because it's always half of your b term. It's always half of your middle term. I promise. I promise. That number is always that half number. It'll come with the plus or minus sign, because half of negative 10 is negative 5. What do you think? Maybe you want to finish solving it. That's why we did it. Just in case you're wondering, when you get to a little crossroads like this, that is, you end up with a fraction. Okay, it's not the end of the world. We are going to have to take the square root of that fraction. That's where we should do a little bit of thinking. Oops, don't forget about the plus or minus. But we should do a little bit of thinking about how to sort of simplify a radical. We have to go back to maybe some algebra ideas, which we can review here. I could take the square root of the top and bottom. In fact, I'm going to. But of course, that has that awful square root in the denominator. I know, I can barely look at it. What did I do? That's pretty important. So here, let's get that negative in there. All right, thank you. That adds an extra imaginary twist to this answer. Still have this square root in the denominator. So let's talk about that. And we can talk about this negative that's under the square root. So You got to multiply top and bottom by root 2. Okay, because you're not allowed to have a square root in the denominator. You also have to get that negative out of there. That negative, sometimes people think of it as that it comes out as the letter I. Really, it's the square root of -1, and the square root of -1 is equal to I. So how's it all look? It's I root 30 over 2. I root 30 over 2. It's just one of those things that when you end up with the square root of a fraction and the square root of a negative number, that we got to do a little cleanup. Something that I did there with that fraction that you have a question on. Are you sure?
I think you just divide 15 by 2.
And get 7.5?
Yeah.
It's kind of one of those math etiquette things. There's a math etiquette book, and if you flip the page to root 2 or whatever, it's just one of those things that it's more appropriate to give your answer in fraction form instead of decimal. Okay, if you do that, you're not going to like fail the problem. I'll probably take a point off, but let me encourage you to try to write your answer as a fraction. It's just more appropriate. Okay, add 5, and I'll make sure I'm doing this right. Yes, if you add 5, now we have 5 plus or minus I root 30 over 2. It's also kind of more appropriate to put the 5 in front. That way we have 5 plus or minus. And again, it just looks like it should. Just by the way, those are 2 solutions. Not that we've forgotten, but we were expecting 2 solutions. They happen to both be imaginary, so they're not going to show up on a graph anyway. And again, the tools that we had up here, well, we need this new tool to enable us to find those roots. I don't know if you need to write this down or not, but I'm going to show it to you just so that you can see some text. Again, for most of us, it's doing this for a problem. When we complete the square, as I said a couple times verbally, the leading coefficient has to be a 1. If it's not, then you have to factor it out. So it's one of those things that you can't just ignore because it's not going to work. So again, the leading coefficient has to be a 1. If not, you have to factor it out. Make sure that you just process that if you need to write it down or put it down in your own words. You saw me do this twice. I promise it's always how it works. You want to group. You want to group the ax squared and the bx. It's really the c that gets pushed out. That's really the purpose of that grouping. Now here's the key step, and I'm trying to give it to you as simple as possible. It's that magic number. It's always half of b squared. Half of b is b over 2. Obviously, when it's squared, we get b over 2 squared. You always add it. Sometimes kids are like, do I always add it? Yes, you always add it because it'll be a positive number. That means then you have to subtract it. Okay? And I'm referring to adding it on the inside, but subtracting it on the outside. Okay, and don't forget that the whole reason we're doing this is so we can actually solve a problem. So make sure you solve it. Try one. Just see if you can make it work with x squared plus 12x plus 76. I was nice to you here. The leading coefficient is already 1. Feel free to take a look if you want to just make sure you completed it correctly. I don't have the solution, but I have basically the factoring. Okay, the cool thing about this method is it allows you to rather quickly get an equation that can be solved with some basic algebra. Subtract 40, take the square root of negative 40. Okay, so subtract 40, take the square root of negative 40. Now, here again, I did this so that you guys would realize, okay, yes, you got to simplify. We're going to end up with the letter I for sure. But how about the square root of 40? Are you envisioning a 4 and a 10? The 4 is perfect. It's allowed to come out. The 4 comes out as a 2. The 10 stays behind. So when it all shakes out, we get plus or minus I 2 root 10. You could put the I on the other side of the 2. Please do not put the I under the square root. That's the only place you can't put it. This would be a little bit more of the place you would see it, but as long as the I is on the outside. Subtract 6. And we have ourselves another one of these lovely answers. Remember, those are the roots, but they're not going to show up on a graph, but still we have solved for those roots. This might be one of the most interesting things that you've seen in a while. I'm building this up quite a bit, so let's see if it's true. What if I try to complete the square on any quadratic equation? Make sure you catch my drift from the beginning here. This is any quadratic equation. What if I solve it for x by completing the square? Well, you shall see, but let's work this out. Now, this is one of those things that's a little higher level. As an honor student, I hope that you're motivated by this. There might be some things that happen where you're like, wait a minute, and you might need to look back at it after class is over. But what we're going to do is we're going to try to use this method very carefully with any quadratic equation. I'm going to get you started. So I factored out an A. Already things are getting a little bit dicey because how do I factor an A off of a BX? Well, don't be so literal. You just have to figure out what's going to be the new term. If I have an A now that's being multiplied back into this BX, then what term needs to be parked here? I'll give you a hint. It's BX over A. Okay, so in a sense, I factored an A off of BX, which leaves me with BX over A. Okay, let's see how we can do the next one. You know there's got to be something that we're going to add right here, right? Let's give ourselves a little bit more space. So we're going to add something. What do we add? Half of this term squared. What's half of B over A? B over 2A. What's half of B over A squared? Well, B over 2A squared. Okay, now I just added B squared over 2A squared. That means I have to take away. Now this is a part that I have to admit even I have stumbled upon a few times, or stumbled with a few times. You have to take into account this A that's been factored out. So what I need to undo is a B squared is a 4, but I'm not going to write down A squared. I'm not going to write down A squared because this A cancels with some of it. So I only have to undo that A. What is going on here? You're allowed to ask questions if you want to. That's a tricky step. Okay. You might feel like that you can contribute here. Okay, I always like to say here, don't think too hard. Don't reinvent the wheel. What number has to go in this spot?
B over 2a.
It's always half of this number, yeah. Trust it. It's always half of b over a. So b over 2a. Okay. Now, over here, I don't know if you realize or not, but we've got some fraction math, fun times, but I'll just fill you in that we need to combine c with this fraction. How do you do that? With the infamous common denominator. Now, if I make a common denominator, I'm able to see the numerator. Look at that numerator, 4ac minus b squared. 4ac minus b squared. And it's all over the common denominator. Why are we doing this? What did you sign up for? We're solving for x, okay? We're solving for x. It's actually at that step where we're ready to do that. Okay, now to solve for x, you have to start moving things to the other side. You're going to subtract this fraction. Okay, now listen, I'm going to subtract this fraction, but I'm going to do it kind of in an intelligent way, sort of a smart way, because all that's going to end up doing is changing the sign of my numerator. So I'm going to subtract this over, but what you're really going to see is the numerator having a sign switch, because that's what it means to subtract. It means to basically distribute a negative, and now my numerator with a negative put on it becomes b squared minus 4ac. B squared minus 4ac kind of has a little ring to it. You can ask, is there anything you want to ask? Okay, some things I just said, but again, we subtracted this fraction. Okay, I can't take the square root yet, right? I have to divide by a. Now, when you divide by a to the other side, and this is always something good for a student to learn, it already has a fraction. So I don't want to put another fraction there. I don't want to do this. That's not good stuff. Instead, I want to understand that to divide by a is to just get another a in the denominator. And if you're looking at that AA and you're saying a squared, you're right. You can even write that as a squared if you want to. We're about a step and a half from the end. What awaits us at the end? Well, take the square root of both sides. Okay, that's going to be the square root of this fraction. The good news is that we can just take the square root of the numerator and denominator. Especially because the square root of the denominator is able to simplify. So that's really good news. The square root of the numerator is just the square root of b squared minus 4ac, but the square root of the denominator is 2a. Some of you are shaking your head no, but what you really are like, yes, it's true. It's true. This solution, you got to subtract b over 2a. Just by the way, when you subtract b over 2a, take a look. I mean, it was made to be this way, but look, your denominators are already common. So if you have a common denominator, you can just put your numerators together. Again, I have a common denominator of 2a, so I can just put my numerators together, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If I didn't have this mask on, you would see a huge smile. I can see it through yours. It's just beaming. Because what did we just do? We just figured out that the solution to a quadratic equation, a quadratic equation is always, it's always the quadratic formula. The quadratic formula. I'm not going to lie to you and say that we just discovered the quadratic formula. We didn't discover it, but we certainly did discover where it comes from. Okay, we discovered where it comes from. So it's not just a random group of letters that the teacher gives you in Alg 2, or maybe Alg 1 if you got that far, but it's really the solution by completing the square. Okay, and it's really pretty neat stuff. If you have a good memory, you'll be glad, because I give this to you as a bonus on the test. If you want to prove the quadratic formula, it'll be guaranteed, it'll be a bonus question on the test. So I'm already telling you that you can practice it if you want. Okay, kids will practice this. It's kind of fulfilling to get it to work out. And some of you might forget that I said that there's bonus, or maybe you're not interested. Okay, but I want to sort of throw that out. It is neat to be able to do this. Now, do you need to be able to do this to complete the square with like regular integers and numbers? No. Make sure that you can do it with regular numbers. Okay, and that's what the homework's for. Just take a listen here. I am using the textbook. Basically, it's just 4 problems, but the directions are being slightly changed. Complete the square.